Hi, I'm Emma Hotchkiss, and I'm going to be talking about strong versus weak acids in this video. And specifically, I'm going to be comparing the pHs of a strong acid versus a weak acid with the same molarity. And this is, the problem is part 3B of exam 3. So these are the instructions for the question. Provide an example for one of the following. Unless otherwise stated, the example must actually exist, and you must thoroughly explain how it satisfies the criteria. You choose the compounds to use and the quantities necessary to answer the question. And you cannot use examples that were used earlier in the exam. So now we get to the question. So we are asked to find the difference in the pH of a 0.0275 molar solution of a strong acid as compared to a 0.0275 molar solution of a weak acid. And we cannot use the X is small assumption. So I decided to use HCl as my strong acid. And here you can see the equation that describes when HCl is interacting with water, we get hydronium ion and chloride. And because strong acids completely dissociate into their constitutive ions, we have for every 1 mole of HCl, we get 1 mole of H3O plus and 1 mole of Cl minus, which also means that the concentration of HCl is going to equal the concentration of the hydronium ions and also the concentration of the chloride ions. We are going to focus on the hydrogen ions because we are going to use this to solve for pH. So all I did was I plugged in 0.0275 molars to this equation because we know that the concentration of HCl is 0.0275 molars, we also know that the hydronium ions are 0.0275 molars. There should be a molars here, should say M. So the negative log of 0.0275 is going to get us our pH. And when you plug that in, you get 1.561. So that is the pH of a strong acid at 0.0275 molar. So for my weak acid, I decided to use nitrous acid, or HNO2. And we were given that the Ka, or the acid dissociation constant for HNO2, is 4.50 times 10 to the negative 4. And so now I have the equation written out for nitrous acid interacting with water. This is aqueous, liquid, aqueous, aqueous. So what we're going to do now, as you definitely know, we're going to set up a rice table. And so here is everything filled out. Because we only have 1 mole of each, because the constants in front of each of these are all 1, we know that this is minus x plus x plus x, as we know. So now I'm going to plug it into this equation. Ka is going to equal x squared over 0.0275 minus x, and that's written here. And so what I did here is I simply rearranged this so that we have it in the form of ax squared plus bx plus c, so that we can use the quadratic formula to solve for x. And we're doing this because in the problem it says we cannot use the x is small assumption. So I'm not even going to try to see if the x is small assumption would work in this case. So here's the quadratic formula, plugging this in for A, this in for B, this in for C. And when we do that, we get that x is 3.30 times 10 to the negative 3. And what x is it's the concentration of the hydronium ions, as we said. Right here, we have plus x, x, x. So we know that solving for x is solving for the molarity of the hydronium ions. And so now that we have that, we can plug it into this equation here. The negative log of the concentration is going to be the pH. And we get, when you plug that in, you get that the pH of 0.0275 molar nitrous acid is 2.481 pH. So now if we're going back to the problem, it's asking us to find the difference between the two. So I brought down both of these, all of this work that we did. It's kind of small, I'm sorry if you can't see it, but it's just to remind us that we had 1.561 as the pH of the strong acid, HCl, and 2.481 as the pH of the weak acid. And so the difference between those is 0.920. And so that's our final answer. Thank you.